Okay, welcome back. Today we're going to cover the greatest common factor. Now, the greatest common factor is also known GCF. So anytime you see GCF, know that that's what we're talking about, greatest common factor. Now, what the greatest common factor means is what number, the greatest or the highest number, can go into both 2 or 3 or however many numbers. In this case, I'm going to start off with 2 numbers. I'm going to look at 8 and I'm going to look at 20. Well, I want you to think about this. Now, those that understand prime factorization, that's the breaking down of numbers. So let's look at 8. Now, besides using 1, what factors can break down 8? 2 times 4. Okay, so now what I'm looking for is this. Can the 2 or the 4 go into 20? Well, in this case, both of them, but you want to take the highest number. I've got 4 times 5. So that means that the greatest common factor is 4. And the reason why is because the 2 and the 5 are prime. You cannot break those down anymore. So my answer is the greatest common factor is 4. Let's try a different one. Let's try 16 and 36. Now, 16 is a perfect square. We can break it down to 4 times 4. 36. Now, I'm going to use 4 because 4 can go into 36 9 times. Now, I do see right off the bat, I do see a 4 and a 4. I can try to break down my other 4 to 2 times 2 and my 9 to 3 times 3, but they don't have anything in common. So that means my greatest common factor is 4. Let's try 24 and 36. Now, with 24 and 36, there's a lot of different variety of ways that we can factor it down. So I'm just picking one randomly. I'm going to pick 2 and 12. And let's just say, now 12 does go into 36, but let's just say we break it down to 6 times 6. Okay, the 2 cannot be broken down. Now the 12 can be broken down to 2 times 6. Now, notice I'm bringing everything down. And the 6 can be broken down to 2 times 3. So 2 times 2 times 2 times 3 is 24. Now in 36, the 2 and the 3 can be broken down. Same thing with the other 6. Now, in this case, what I want to do is I want to say, okay, I've got a 2. I'm going to just circle them, a 2 and a 2, a 2 and another 2. But now I don't have a 2 on the other side with the 36. But let's look at the 3. I've got a 3. Now this case, I've got a pair of 2s and a 3 that they have in common. So when you have this, what you want to do is you want to take 2 times 2 times 3, and this will give you your greatest common factor. Now notice what I said before. I'm going to circle this 12 right here. 12 right here would go into 36, and that would be your greatest common factor. But sometimes we break them down, and we don't really notice it. So this is just showing you can break it down to get this 12 a different way. Now, let's say I have 3 different numbers. Now, what numbers do they have in common? Well, I'm going to say 4 can go into 8, 4 can go into 12. So I may just break this down to 1 and 4. This would break down to 2 and 4. And this would break down to 3 and 4. So notice something on this one. The 4 they have in common. And what's left over, can't do anything with the 1, it's prime. 2, you cannot break down its prime. 3, you cannot break down its prime. So in this case, the greatest common factor would be 4. Say we have 18, 30, and 36. I can break down the 18 to 2 and 9. The 30, maybe you say 3 and 10. And maybe 36, instead of using 6 and 6, maybe we use 3 and 12. Now, I can't do anything with the 2, but the 9 I can break down to 3 and 3. The 3 I bring down, the 10 can be 2 times 5. And finally, the 12 may go 3 and 4. Now notice something. It doesn't matter the order of 3 and 4. It can be 4 and 3. It doesn't really matter. Now, on all of these, except for the 36, I cannot break anything down. But on the 4 right here, I can break that down into 2 times 2. So now we need to pair these up. Do they have a 2 in common? Well, let's see. 2, 2, and 2. 3, 3, and 3. So that means I'm looking at this next 3 right here. I just have a 5. I do have a 3 right here, but they all have to have that in common. So that means what is left is 2 times 3, which equals 6. So next, let's try one more of these. Let's try 12, 18, and 36. So I want you all to think about this too, because when you factor these out, it doesn't matter which ones you use. So for 12, some of us may use 2 and 6. Others may use 3 and 4. Same thing with 18. Some of us could use 2 and 9. Some of us can use 3 and 3, and so forth. So I want you to take a moment and see if you can do this one yourself. Okay, so for 12, maybe we use, and we're going to start to see what they could have in common. Well, let's use 3. 3 and 4. Let's use 3 and 6. And let's use 4 and 9. Three cannot break down, but the 2s can, or 4 can break down into 2s. The 3 cannot break down, but the 6 can break down to 2 times 3. And finally, your 4 can break down to 2 times 2. Your 9 can break down to 3 times 3. So now what I'm going to do is I'm going to look at the 3. I've got a 3, I've got a 3, and I've got a 3. Then I've got a 2, and a 2, and my third 2 does not pair up with anything. So in this case, 2 times 3 would give me 6. Now some of us in here could look at 12, 18, and 36 and say, okay, 6 can go into 12 twice, 6 can go into 18 3 times, 6 can go into 36 6 times. So we can point out 6, but this is just showing you other ways if we do kind of get stuck on something. Now for the bonus, let's say we have 11 and 17. Now some of us are looking right now and seeing that this is prime because 11 can just be 1 and 11. Same thing with 17, 1 and 17. Do they have anything in common? The only thing they really have in common is the 1. So in this case, the greatest common factor in this case is 1. Now be looking out for my second part of this greatest common factor. I'm going to start introducing some variables or letters on my next video. Thank you for listening.